16 stadiums, 3 countries, 1 month. The 2026 World Cup kicks off this June, the biggest sporting event on Earth. And the hardest engineering problem isn't the stadiums, isn't the broadcasts, isn't security for 32 national teams crossing a continent. It's the grass. 5 years of research, tens of millions of dollars, all for the stuff under the players' feet. But here's something that might surprise you. More than half the venues don't have any. 7 of the 11 NFL stadiums picked for the World Cup, nothing but artificial turf on concrete. MetLife Stadium, hosting the final, concrete floor. Dallas, sealed dome, 0 sunlight. Every single one needs a FIFA standard playing surface before the first whistle. And every single one goes back to fake turf the moment the tournament ends, built to be destroyed. What exactly goes on top of that concrete? The answer starts in a carpet factory. 1989, a Dutch textile company called Desso, not a sports company, a floor covering company, figured out something weird. The technique they used to tuft fibers into carpet backing. It worked on football pitches. Stitch thin plastic strands deep into the soil. Let the grass grow around them. The roots grip the fibers. The surface becomes 4 times more durable. 1992, FC Den Bosch installed the first professional hybrid pitch. Late 1990s, Wembley had it, Camp Nou had it, Anfield had it. A carpet company from Brabant had quietly resurfaced the biggest stadiums in European football, and nobody outside the groundskeeping world even noticed. Now here's the kicker. None of that works for 2026. Those pitches sit on natural soil. They're permanent. Full-time groundskeepers maintain them year-round. The World Cup needs the opposite, temporary surfaces, built on concrete, inside stadiums designed for American football, in climates that range from 90-degree Miami heat to a sealed dome in Dallas with 0 natural light. 2021. FIFA walks into the University of Tennessee, sits down with Professor John Sorochan, and hands him the problem. 16 stadiums, 3 climate zones, concrete floors that have never held a blade of grass. And the ball has to bounce the same at every single venue. Sorochan and Professor Trey Rogers at Michigan State spent the next 5 years on it. Built an entire research facility, the FIFA Shade Building, solely to figure out how grass survives without sunlight. The method they developed, growing turf on sheets of plastic instead of soil, came straight out of that lab. 88 miles of turf grown for 1 tournament, 45,000 man-hours, 15,000 tons of materials. So after 5 years, this is what goes on that concrete. What goes on that concrete isn't grass. It's 6 layers. Grass is just the surface. MetLife Stadium, World Cup final venue. Right now, bare concrete under artificial turf. Crew strips the fake surface. Everything comes out. They build from the bottom up. Layer 1, hollow plastic drainage tiles across the concrete. Light, shock absorbing. Layer 2, 2 feet of sand. Layer 3, irrigation pipes, every direction. Layer 4, ventilation that sucks excess water out and pumps fresh air down to roots. 4 layers of engineering, not a single thing growing yet. But here's the thing. The grass itself doesn't come from the ground. Farms hundreds of miles away. 2 grass families. Bermuda for hot outdoor venues like Miami and Houston. Kentucky bluegrass blended with perennial ryegrass for cooler and indoor stadiums. 2 different plants, same tournament. Workers laid plastic flat on the ground, spread 2 inches of sand, sowed seed. Grass grew up, but when roots hit the plastic, they couldn't push through. Turned sideways, tangled together, locked into a tight, woven mat. Workers peeled the surface off the plastic, rolled it like carpet, loaded it onto refrigerated trucks, rotating drivers, around the clock, because the grass is alive and stopping too long kills it. But 2 inches of sand on plastic is fragile. 1 heavy rainstorm washes the entire crop away. 20 truckloads arrive at MetLife. 600 rolls, laid edge to edge across the sand. 2 days to cover the entire pitch. But the rolls aren't connected yet. Seams everywhere. Surface still fragile. Then a machine the size of a tractor rolls in. A giant sewing machine on wheels. It punches 20 million thin plastic fibers down through the sod 8 inches deep. Tight grid, every direction. As roots wrap around each fiber the way a vine grabs a fence post, the seams disappear. 600 separate rolls become one surface. 97% grass, 3% synthetic. Can't see the difference. Can't feel it under your cleats. Regular turf wears out at 250 hours of play. This handles 1,000. Roots never cut. Playable almost immediately. Some World Cup matches happen 10 days after installation. 10 days. In Dallas, sealed dome, zero sunlight, 18 pink grow lights hanging from the ceiling, 12 hours a day, just to keep the surface alive indoors. Houston, the stadium hosts a rodeo through March, so the pitch can't go in until weeks before kickoff. Denver grew the cool season sod, then shipped it over 1,000 miles to domed stadiums in Texas. Mexico City, 7,000 feet of altitude, thinner air, completely different grass behavior. Every stadium a different problem, every pitch built from scratch. 6 layers, 20 million fibers, 600 rolls, 2 days, gone in 2 weeks. Your first instinct? Waste. Millions of dollars for something that disappears in weeks. But Professor Rogers sees it the other way around. The speed is the point. Build a pitch on Tuesday, play a match Saturday, rip it out, hold a concert Sunday. A stadium doesn't have to choose anymore, doesn't have to commit to one surface, doesn't have to tell the NFL no, so FIFA can say yes. The disposable part isn't the flaw, it's the breakthrough. If concrete can become a world-class pitch in 48 hours, the argument for permanent artificial turf starts to collapse. Not because of pressure, because the engineering finally caught up. And here's the thing, nobody's saying out loud, this system's never been tested at this scale. Hybrid pitches exist at individual stadiums around the world, but 16 of them simultaneously. 3 countries, concrete floors, outdoor heat, zero sunlight domes, all performing identically. That's never been done. The first full-scale test isn't a trial run. It's the World Cup. If a pitch fails during a knockout match, there's no backup. So let's go back to that MetLife concrete floor. You know the grass in Miami and the grass in Dallas aren't even the same species, and they're both supposed to feel identical under a player's cleats. You know sod grown in Denver gets loaded onto refrigerated trucks and driven over 1,000 miles to a sealed dome in Texas, because the grass can't survive there on its own. You know the technology behind the World Cup final started in a carpet factory in the Netherlands, and took 2 American professors 5 years to turn into something that works on concrete. And the next time you watch a match this summer, you'll look at the pitch and realize the simplest looking thing on screen is the most engineered thing in the entire building. That's the process. We reveal how things actually work, one story at a time. If there's something you'd like us to explore next, let us know. Until then, trust the process.